Welcome to the next video. So this is another video in which I am solving a previous KTU problem. So this is a problem which was asked for MOS S3 Civil. It was asked for 14 marks. It was asked in 2019 May. So it's a very recent problem, question paper. This is a tricky question. Normally this is from module 5 column section. So normally whatever problems I have solved till now, all the problems involved a circular section. Now it is a rectangular section, and there is a small challenge in rectangular section. If students are not careful, they can make some mistakes. Now I'll read out the question. A hollow rectangular cast iron column having outside width and depth as 250 and 500, these two are in mm, and thickness 20 mm, is fixed at one end and hinged at other end. The length of the column is 8 meters. Calculate the safe load that can be applied on the column, assuming a factor of safety of 4. Use Rankines theory. Take the alpha or Rankines constant. Sometimes it is called as A also, as 1 in 1000, 1 in 1600. And sigma C, which is the compressive strength of the material, as 600 MPa. Compare the value by Euler's theory. Take E equal to 95 kN per millimeter square. So it's a big question and it is having a huge marks also. Now we will get the given data here so that we will understand what we are dealing with. So the length of the column is the first thing that I am going to draw. So it's a column. The boundary condition is fixed at one end. So this is fixed here. It's hinged at another end. Okay, it's hinged at another end. Hinged, fixed. So length is 8 meters. So the moment you get a length of column and the boundary condition, you have to straightforward find effective length. So effective length of a column when one end is fixed and other end is hinged is nothing but original length upon root 2. So this comes to be 8 upon root 2. Okay. So please ignore the value in the calculator. So we'll just calculate this. 8 upon root 2, which is nothing but 5.657. 5.657 meter. That is 5657 millimeter. This is the length, effective length of the column. So that portion is done. And now it is a square column. So it's a hollow rectangular column. So let's draw that. So this is the outer dimension which is given. Outer dimension is given as 250 by 500. So this is 250. This is 250. This is 500. Okay. And there is an inner dimension. The thickness of the column is also given. So we'll just draw that. Right. So this is the column. So thickness is given us. What is the thickness is given us? 20 mm. So it's the thickness is huge. So it's a big thickness. Okay. It's a decently big thickness. So let's draw that also. So we'll take black color, 20 mm. Okay. Now we can find different properties of this section. Now the main. Okay. Now what else is given? I will complete all the given data. So calculate the safe load applied, assuming factor of safety 4. Factor of safety is to be assumed is 4. And Rankines constant A or alpha is given as 1 upon 1600. Okay. Then E is given as 95 into 1000 MPa. So these are the values given. And sigma C is also given. It is nothing but 600 MPa. So it's high strength. Okay. Now, first we will use Rankines theory to find the buckling load. So Rankines theory, the strength of the column. So Rankines theory, the strength is given by. So let's say . Rankines, the strength of the column is given by sigma c into area of column divided by 1 plus Rankines constant into LE upon K, the whole square. Now what is K? K is nothing but radius of gyration. It is actually not radius of gyration, it is minimum radius of gyration or least radius of gyration. Least radius of gyration. Now how do you find radius of gyration? So we have to equate I equal to AK squared. Okay. Now the problem with this section is, so till now the previous questions that I have done, all the sections are circular. So in any direction you find the value of I, it is same. But for a rectangle section, you can have two I's. So major the two directions are there. In these two directions, we can have different I's. Okay. So there is an I in this direction, there is an I in this direction. So which I we have to take? So that is a question here. So that is why this least term is important. Okay. So first we have to take the two I's. Out of the two I's, so area is constant. So whatever I is there, depending upon value of I, the value of K will change. So least means we have to take the least value of I. So we know that for a rectangle, the least value of I will be when we take moment of inertia about this section, about this line. Okay. If you take moment of inertia about this line, we'll have higher value compared to this value. So I have to take in a small section. So what I will do, I will mark the sections here. So let's say this is XX, this is XX, and let's say this is YY. YY. Okay. So I will have to take IYY. So what is IYY for rectangle section? So IYY is it is nothing but 500 into 250 cube by 12. So this hollow, I have to reduce the I of the inside rectangle. So inside rectangle, the dimensions are 250 minus, so this dimension is 500 minus 20 minus 20. So 500 minus 40, that is 460. So 460 times this dimension is 250 minus 20 minus 20. So 250 minus 40, that is 210. 210 cube upon 12. Okay, I hope this is clear. So again, I'll just draw it here if you're confused. So if this is B and this is D, moment of inertia about this axis is BD cube by 12, and moment of inertia about this axis is DB cube by 12. So this DB cube is what I am taking this. Okay, so D is 500, B cube. Now since it is hollow, from the outer rectangle moment of inertia, I have to reduce the inner rectangle moment of inertia. So that is what I have done here. Okay, now I am not taking this value because, as I told you, in this formula, the K value that you have to use will be the minimum. To get the minimum K value, you have to take the minimum I value. So this is the most confusing part of this problem. If this is clear to you, so if you take the IXX, this value, what you will get is you will automatically get a higher value of K. Now I'll just calculate this and find the value of I. So what is this value? Let's calculate this. So this is 500 times 250 cube upon 12 minus 460 times 210 cube to the power 12. So this gives me 29603666. So 29603. So 296036666. So 6667 mm to the power 4. So this is the value of IYY. Now what is the area? Area of this is nothing but 500 times 250 minus 460 times 210. Okay, so this comes out to be, so we'll just quickly calculate. So area calculation, I think it is clear. 500 times 250, so times 250 minus 460 times 210. So this is 28400. 28400. So that means the minimum value of K, or I will write that as KY. KY is Iyy by A under root. So this is nothing but this value by this. Okay. So 296036667 divided by 28400 under root. So we just do that. So this is nothing but under root of 2960367 divided by 28400. So this is 102.1 mm. So this is the value of K. 102.1 mm. This is the value of K. Okay, so this is the value of K. So now we have found all the values. Area is there. All these values, we can find the Rankines load. Okay, load at which fails. So just we'll calculate it here. So P equal to sigma C. What is the value? Sigma C is given as 600. Area is given. We have already calculated area 28400. So remember, I am following this formula here. 1 plus, what is the value of A? 1 upon 1600 into, what is the value of LE by K? LE is, we have calculated the value of LE. LE is 5657. So 5657 divided by 102. 102.1 square. Okay, so this is what we have to solve. Now, this is, we have to be careful while doing this. So let's say I have 600 times 28400 divided by 1 plus, so 1 upon 1600 times 5657 divided by 102.1 to the power square. Okay, so I think it is clear. So this is the formula. The entire formula is there, right? So this is 5838270 Newton. So 5838270, 5828370 Newton is the force. Okay, so this is the force it can take, axial force it can take according to Rankine's theory. Now we have to use a factor of safety of 4. So before that, I will just convert this to kilonewton. So this is 5829 kilonewton. Okay, approximately. So safe load is Rankine's load divided by factor of safety. So this is 5829 divided by factor of safety is 4. So that gives us 5829 divided by 4. It is nothing but 1457.24. 1457.25 kilo. Okay, this is the safe load. So this is the first part of the problem. So this we have done. Now what they are telling, compare the value with Euler's theory. Okay, now we just have to compare the value with Euler's theory. So we will do it here on the side. So let's say Euler's theory. Okay, so P Euler's theory, buckling load is given by pi square E I upon L E square. Now instead of this, we can also write pi square E. Here also we have to take the least value of I. Okay, least value of I. So this is E into I can say I into A into ky square upon Le square. So this will come out to be pi square Ea upon Le by k square. So this is ky. Okay. So now you should substitute the value. So you can also substitute the value of I which you have found here. That is also okay. So I have just slightly, I think I have complicated this for you, but I think we can do this, right? So just substitute the values. All the values are here. So I'll take up the calculator. So quickly we will calculate this and finish our problem. So pi square E, what is the value of E? 95. 95 times 1000 times, what is the area? 248,28400. Area is also visible here, divided by, so LE, effective length is 5657. It is given here 5657, divided by KY. What is KY? 102. Okay, we have to square this. So this gives me the Euler's load, that is 8674027. 8674027 Newton. So that is nothing but 8674 kilonewton. Okay. Now safe load. Safe load is 8674 divided by 4, which is nothing but, so 8674 divided by 4 is 2168.5 kilonewton. 2168.5 kilonewton. This is a safe load. Okay, so this is how the value. So Euler is giving me a higher value compared to the Rankines formula, right? So this is the final answer. These two. Now be very careful. The most confusing part of the problem is which I you have to take. Since it is a rectangle, we can have two I. So we have to take the I which gives the least value. Okay. So this is also known as the weak plane or weak plane, because the column will be buckling in that plane. Okay. So this is not, you don't have to worry about this in circular section. All the previous problem was circular section, so this worry was not there. This is given a rectangular section, so this is slightly challenging. So for working out, you can also work out the value of IXS. With IXS, you can find the value of K, and you can again recalculate this. Always you will find that the value of the loads P will be higher than these two if you take IXS. Okay. So deciding this, which I we have to take, is very, very crucial. Okay. I hope this is clear. We will solve another problem in the next video. Thank you.